Okay guys, hey guys, well technically this is our last real video, and we are going to be on 5.6 writing systems of linear equations. It's our last real video for 2020. There is going to be an optional video tomorrow night that if you watch it, it's going to help you get some bonus points towards our review game that we're going to play on Wednesday. So it's not mandatory, but if you do watch it, then it could help you get some bonus points on the video, and it's going to help you review a little bit more for your test. That's the most important thing. It's going to help you get some bonus points towards the game on Wednesday, and we're going to be playing attack on Wednesday. So before we get started on this, I want to go back to this page. Page 11 in our notes. We didn't quite get to this in class today, so I wanted to explain it, but today in class we learned how to put things in the calculator and y equals, and then we learned the function where you can press second, trace, enter, 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 and that's going to give you the intersection in the calculator. Well, you also could go to the tables, and you would be able to look. If you saw two sets of tables instead of equations, if you just saw two, this would be like equation number 1, and this would be equation number 2 table, all right? You would look and see where the points have the same x and y values, and whatever is the same point there is where they would intersect. So like this one here there's a -4, 6. Well, this one also has a -4, 6. So that's going to be where they intersect. That makes sense. Okay. On this one, do we have any where they intersect? Yes. We have a 5 and a 9. We have a match 5 and a 9. So that's going to be where they intersect. That's how you can tell just from looking at tables. Okay. So I wanted to show you that really quickly. It's super easy. You just have to see where they match, and that's the solution. Okay, we're going to talk more about that tomorrow at the beginning of class, but this is what we're getting to in our video today. I know this is all of everybody's favorite. It's word problems. So we're going to be writing systems of linear equations with word problems. So just like any other word problem, you have to identify your variables, but this time there's going to be 2 variables. We're going to formulate 2 equations instead of only 1. And then you get to determine the best method for solving. So we have, these are our methods here. We have graphing, which unless you have graph paper, it's not going to work very well. We have substitution, we have elimination, and we have calculator. Alright, so you know some of these require you to have both equations in y equals form. This one and this one, you have to have both in y equals. Okay, this one has to be in solved, one solved for x or y, and in elimination, neither of them have to be in y equals. You just have to be able to cancel a variable. Okay, just a little review. All right, let's look at number 1. The perimeter of a rectangular desk is 175 feet. Perimeter is 175 feet. The length of the deck, which they're calling L, is 6 feet longer, than 2 times the width. What's 2 times the width? Sorry, I mean to include that. Which system of equations can be used to solve and determine the length, width, and feet in the deck? So we're just setting them up right now. Okay, we're not actually solving for x and y. We're just setting them up. Alright, well, so this time we don't have an x and a y, we have an L and a W because it's length and width. So the length of the deck L equals 6 feet longer, so 6 plus 2 times the width, 2W. That's going to be one of them. And then we know the other equation is going to be dealing with the perimeter. if the perimeter of a rectangular desk is 175, what does a perimeter tell you about length and width? When you add them up, you have 2 lengths and you add 2 widths. Remember, of a rectangle, you have two L's plus 2 W's. That's where we get 2 length plus 2 W. 2L plus 2W. Alright, so these are going to be your 2 equations. Which of these options has this in there? Looks like option D. Right? The only thing that's different is that the 175 is on this side, but on the opposite side of the equal sign, but it's the same. Okay? So if you're going to solve this, you would pick which way you would like to solve it the best, and we'll do that in class tomorrow. And then you solve. Just like we've been solving. Alright, so here's another one. The Mendez family is going to see a play. The adult tickets cost $9, and children's tickets cost $6. So, A is adult, and C is children. So, adult is 9A, and children's tickets cost $6, 6C. Alright. So we have to figure out what our equations are going to be. Alright, we know that there are 9A plus 6C is going to have to be 48 because it tells us right here. They spend a total of $48. Alright, that's one equation. Another equation is that there are 6 people in the family. So adults plus kids plus children is going to equal 6. So I'm going to write my other equation down here. Which one of these, do you see this anywhere? A plus C equals 6. 9A plus 6C equals 48. This would be it. Okay. Let's do this one. A box contains 22 coins consisting of quarters and dimes. The total value of the coins is $3.25. Okay, so dimes plus quarters equals 3.55. Oh, wait. No. That's not the total. 22, I meant. There are 22 coins. We don't know how many dimes or quarters, but there's 22 total coins. So dimes plus quarters is 22. We're just going off the number of coins. Okay, that's the first equation. Alright, so we know dimes are 10 cents. So if dimes are 10 cents, that's 0.10 times D. That gives you the amount for dimes. And then quarters are 25 cents. So plus 0.25 times the number of quarters. That's going to give you $3.55. So that's your other equation. So do you see these 2 equations anywhere? Dimes plus quarters is... Well, this one looks good, except for it's not in... There's no decimals. And we know there's a decimal in our answer. So it can't be A. Could be B. Nope. Alright, so the only difference between here and here is this. There's no decimal in this answer. So it can't be D, so our answer is B. So we're just going to set it up today. And then we're on our last one. When shopping for school supplies for her children, Mrs. Michaels bought 2 sets of markers and 3 binders. So markers are M, 2 sets of markers, plus 3 binders. I'm going to assume that's B. Yep. For a total cost of $21. Okay, so she bought two sets of markers, 3 sets of binders for $21. We also know that she bought 5 of the same sets of markers and 2 of the same sets of binders. Oh, wait. Yeah. 5 markers and 2 binders for $25. Okay, so look. That's that equation. 5 markers and 2 binders for $25. That's that equation. So do you see where these 2 equations are used? 2m plus 3b is 21. 5m plus 2b is 25. Looks like B is our answer. Alright, so we've set these up. Tomorrow I'm going to show you how we could best solve them. That's it for tonight. Have a good evening.